Hello everyone, welcome back. In previous lecture, I explained about the limit system, then the geometric tolerance. Now in today's lecture, we will further move on to the geometric tolerance. Let us recall first. We explained about the basic limit systems, pole basis, shaft basis system, in the Indian standard system of limits and fits. Then after Indian standards of limits and fits, the geometric tolerance I explained about. So why geometric tolerance is necessary? Because you can see the component, if we take this cross section, it will be same throughout the section, but it is not the same. Okay, so here the thickness is also same throughout, but here the component is having the varying section. Same way for the circular shaft. So the geometric tolerance, you can see that is the one type of 3D tolerance. On the three dimensions, we have to check the size, shape, and size of the component. Now we will see the terms used in the geometric tolerance. So the first term is the datum. Datum is theoretically exact geometric reference such as an axis or a plane or a straight line to which the tolerance feature are related. Suppose if we want to measure any component, we require any datum. It can be any axis, it can be a plane, or it can be a straight line. So which is the tolerance feature are related to which we will measure the component dimensions. Then the datum features. Here the datum feature is a feature of a part such as an edge or surface or a hole which forms the basis for a datum or is used to establish its location. Then this is the datum feature which is used. It can be edge, surface, hole, which forms the basis for a datum and used to establish its location. Then there is the datum triangle. You can see in the figure, this is the datum triangle. The datum triangle is indicated by a ladder line and it is terminately to the in a filling or an open triangle. It is terminating in a filled or an open triangle. You can see in the figure, this is the datum letter. After datum letter over here, this is the leader line. The datum is indicated by this leader line. This is the tolerance feature arrow over here. Then symbol for the tolerance, its value and the datum letter. Then there is one datum letter which is to identify a datum for reference purpose. See, a capital letter is a enclosed in a frame and connected to the datum triangle. So here the for the purpose of reference, we have to identify the datum. So we will indicate by a letter and it is connected to the triangle. Now the datum system. Datum system is a group of two or more separated datums used a combined reference for tolerance feature. In this case, the sequence of datums referred has considerable influence on the result. Here you can see how the primary datum plane is over here. Then there is one secondary datum plane and tertiary datum plane. And this one is the base and this is our component. Then indication of geometric tolerance on drawing. To eliminate need of descriptive notes, geometric tolerance are indicated on the drawing by symbols, tolerance and datums, all contained in component of rectangular frame as shown in figure over here. Then the advantage of using geometric tolerance, that the geometric tolerance convey very briefly and precisely the complete geometrical requirement on engineering drawing. The use of symbols and boxes eliminates the need for lengthy descriptive notes and corresponding dimensions, because of which the drawings are much clearer to read. Now, the symbols used are internationally recommended. Then, one type of geometric tolerance can control the another form, and for instance, the surface can correct the flatness and straightness. So, if we conclude over here the advantage of using geometric tolerance, that it is very much precise than the complete geometric requirements for the engineering drawing. Use of symbols uh, and boxes eliminates the lengthy descriptive notes. It doesn't require any lengthy descriptive note for the corresponding dimension, internationally recommended, and can control another form such as flatness and straightness. The indication of feature control. The feature controlled by the geometric tolerance is indicated by an arrowhead at the end of ladder line from the tolerance frame. Now the tolerance frame is connected to the tolerance feature by a ladder line and terminating with an arrow in following ways. On the These are the various indication feature, the various symbols on the outline of the feature, on extension of the outline, but not a dimensional line. When the tolerance refers to line or surface itself, the table shows the symbol representing characteristics of tolerance. Here you can see in the figure the characteristics to be tolerance and the symbol over here. First is the form of single features, the straightness, flatness, circularity, roundness, cylindricity, profile of any line, then profile of any surface. These are the forms of single feature, which means the straight, flat, circular, cylindrical, which means cylindricity, then the profile, any line, then any surface. These are the form of single feature. Then the orientation of related feature, which means it is parallel or perpendicular, which means the squareness, angularity. These are the orientation related features. Then the position of related features, which means what is the position at where it is located. Concentricity, which means if two shafts are concentric or coaxial, it is perfect. For that we use this symbol. Then symmetricity, if the two parts are symmetric or not. Then run out, if the part is on form of run out. So if we use these types of symbol for indication of feature control. So this is about the geometric tolerances. Now we will move to the next topic, which is very important, that is the limit gauges. And gauges are inspection tools which serves to check the dimension of the manufactured part. And the limit gauges ensures that the size of the component lies within the specified limit. There, they are not non-recording and do not determine the size of part. Gauges are standard and limit gauges, also called as go and no go gauges. They are not recording any dimension like vernier caliper or micrometer. They are just used for checking that the dimension is within our limits or tolerance is same or not. So it is acceptable or not, it is checked only by the gauges. The standard gauge are made of to nominal size of the part to be tested and have the measuring member equal in size to the mean permissible dimension of the part to be checked. The standard gauges are of nominal size and have the measured member equal to the in the size to the mean permissible dimension of the part to be checked. Then there is the limit gauges, which are go and no go gauges. These are made to limit the sizes of work to be measured. They are specifically designed to limit the size of the work to be measured. On one of the sides or ends of the gauge is made to corresponding to maximum and the other end is to minimum permissible size. The limit gauges are having the two side. One is having the maximum permissible value and the another is having the minimum permissible size. So the function of the limit gauges is to determine whether the actual dimension of the work are within the outside specified limit or it is not. Okay, so the it is used to determine the actual dimension of the work whether it is within the outside specified limit. A go no go gauge is a measuring tool that determines does not return a size in the conventional sense but instead returns a state. The state is either acceptable, the part is within the tolerance and may be used, or it is unacceptable and must be rejected. So go and no go gauge is measuring tool that does not return a size in conventional sense but instead return a state, whether the part is acceptable or it will be rejected. They are well suited for the use in production area of the factory as they require little skill or interpretation to use effectively and have few, if any, moving part to be damaged in often hostile production environment. So where the large scale manufacturing is going on, these types of gauges are mostly required. Then why limit gauge is necessary? So here is the question. So the answer is that the in manufacturing firm, the components are manufactured as per specified tolerance limits, whether the upper limit or the lower limit. So the dimension of the each component should be within that upper and lower limits. So if the component are outside these limits, component will be rejected. That is but obvious. If we use any measuring instrument to check this dimension, process will consume more time. If we use vernier caliper, micrometer, other measuring tools, it will take a lot of time. Also in mass production, we are not interested in knowing the amount of error in dimensions. Okay, so it is just enough whether the size of component is within the prescribed limit or it is not. For this purpose, the limit gauges are used. Okay, so a limit gauge is not a measuring gauge. This gives the information about the products which may be either within the prescribed limit or it is not within the prescribed limit. By using limit gauge report, the control chart of P and C are drawn to control the invariable of the product, and this procedure is mostly preferred by the quality control department of the each and every industry. Okay, so a limit gauge is not a measuring gauge but just gives the information about the product which may be either within the prescribed limit or it is not in the prescribed limit. So by using the limit gauges report with control chart of P and C, are drawn to control invariable of products. This procedure is mostly preferred by the quality control department of the each and every industry. The limit gauges are mainly used for checking for cylindrical holes of identical component within with a large number in mass production. So this is it for today's lecture. Thank you very much for listening carefully. Have a nice day.